To introduce our next speaker for the day, we now request Mr. Siddharth, Chapter Council Member, to introduce Mr. T.S. Rao, Chief Operating Officer, Madras Engineering Foundry Division, to our audience.
Good afternoon, all. It's my immense pleasure to introduce Mr. Srinivasa Rao, who's a very, very common face amongst our IAF fraternity. I think I myself might have introduced him for like 5-6 times in this last 1 year. So, a few information about him. He's done his Masters in Public Personal Management, MBA in TQM. He's a certified lead auditor for almost all certifications, including PED. Dale Carnegie trained leader, Lean Six Sigma black belt, global mentoring by Roundtable in Canada. He has 36 years of industry experience in various positions, has traveled to over 15 countries for supporting quality and productivity improvement, developed over 2,000 new cash products from APQP to PPAP, 20 years in Hinduja Foundries Hyderabad, 1 year in Hindustan Motors Kolkata, 2 years in Dakshin Foundry Bangalore, 1 year in Pitti Castings Hyderabad, 12 years in Armstrong Fluid Technology Bangalore, and he is currently with Madras Engineering as COO. His area of expertise include thorough foundry industry knowledge, design and drawing in 2D and 3D, strategic business planning and execution, lean process and world-class manufacturing, high productivity with collaborative teamwork, risk management and mitigation, financial accountability including P&L, global business operations, Six Sigma approach for reduced variance. A well-round and talented person. We please have you on stage, sir, for your presentation.
Good afternoon, Foundry fraternity. Thank you so much for IIF for giving me opportunity to present, it's sharing the knowledge. I don't believe like training the people or taking the lecture. It's only the sharing knowledge. What I learned from the industry, from the people around here over the years, I just wanted to give back to the society, give back to the Foundry fraternity. That gave me more satisfaction. But the introduction made me small. So we are just back from the lunch. So what we do is, the theme today is like good to great and to the excellence. We are all good, I'm sure. We are all good. That is why we are here. And certainly some of us are great, no doubt. And from here, how do you go to excellence? That is the theme of the presentation today. Let us go through that. So what we do is, before we go to the main presentation, we have a small tip to the audience, small question. Just check who is the gentleman here in the picture. So can someone guess who is he? No? Okay, I'll give one more clue. So hopefully you will get now. No. No. Excellent. He is Buzz Aldrin. So the next person, I think everyone should be knowing, Neil Armstrong. Okay, so Neil Armstrong known to us, but let us go to 21 July 1969 when Apollo 11 mission was launched by US NASA. So there was a confusion. The space shuttle contains 3 gentlemen, like as we know, the Neil Armstrong, who was a commander, and Buzz Aldrin, who was a lunar module pilot, and the Michael Collins, he was the command module. So there was a confusion who has to step out of the moon first. There were 2 scenarios. Who is the first line of defense? Normally when the first line of defense, junior we go first to fight, senior follows. And second scenario was who has to step down where the door opens, because there was 2 doors, one is on the left, one is on the right. So there was a little confusion on 21st of June 1969. So when they were all thinking that no, the Buzz Aldrin was the person who was a commander who has to get out first. Then unfortunately the door opened on the right side, but Buzz Aldrin was on the left side. So if Buzz Aldrin had to get down from the space mission, he has to cross over the Neil Armstrong with a heavy suit. It was humanly it was impossible. Then he was hesitating whether to get down to trouble him or wait. So there was a time delay of 2.5 seconds from land to moon. So they were thinking that Buzz Aldrin already landed. Then they said second in command. So Neil Armstrong, like our Foundrymen, he was waiting for the opportunity to jump. Because the door opened and the Neil Armstrong said he quickly jumped out of the moon and he recorded a history. He is the first man on the moon. He landed. So that is the reason no one knows Buzz Aldrin. No one knows even Collins. Because Collins did not even land. Because 19 minutes later, after Neil Armstrong, Buzz Aldrin also landed on the moon. But Michael Collins, he stayed back because he has to hold the spaceship intact. So that was the story behind this. Let us learn a few points from the story. So world only recognizes first. So clarity in communication, that's more important for us. Apprehension on what can go wrong, like Buzz Aldrin was little apprehension because whether to jump over Neil Armstrong or not to jump. And hesitate on troubling others. And active listening, like dynamic decision making. So assessment of communication gap. So these are the lanes for us today. Let us go to the main subject. So good afternoon team again. My name is T.S Rao, Srinivas Rao, known as T.S Rao. I work for Madras Engineering. So about Madras Engineering, we started in the year 1966 with a machining component division. Today we are the world's second largest slack adjusters manufacturers. Then we always say drive safe, trust the leader. We are the leaders in the business. So we are largest slack adjuster manufacturers in the country, second in the world. We have 5 manufacturing plants, all in and around Chennai. These are our manufacturing plants. And we have our own in-house R&D unit. And we are vertically integrated with the Foundry division. And we are the trusted partner for auto OEMs in India and abroad. Global footprint, you can see from here our parts fly all over the world. Coming to the Foundry division, so we established the commercial production during the year 2013 with the installed capacity of 12,000 metric tons per annum. We added second molding line to enhance the production capacity to 24,000 tons per annum during 2018. We are now operating with full capacity. Apart from producing in-house, we also buy about 3,600 metric tons per annum from outside foundries. So we have unique features in our Foundry division, like we produce only ductile iron. And we have 2 separate lines, both are these are C3 lines. They work independently and also they work simultaneously. That is a unique system we have in our foundry. We have safe liquid metal handling. We have 6-axis rabo, so that carries metal direct from the furnace till pouring into the tundish. Even the magnesium treatment is also done by the robo. And we have Preci-pour for pouring molds. We have hydraulic trimming to eliminate manual fettling. We have single piece flow. So melt to ship is about 6 hours. That is why our inventory turns are close to 50 times in a year we rotate our inventories. So we produce 1 million parts from 423 various products. And 2 rain harvesting ponds to store 15 million liters of water, which caters 60% of our plant capacity. So 76% of the power what we use is from the renewable energy. So this is a brief introduction of the Foundry division. So out of the plant capacity, 42% goes for the captive consumption, 38% to the OEMs export, and 20% is for the domestic OEMs. The objectives of this presentation, as I explained, we are here to share the knowledge, not to teach Foundry people. We are all experts assembled here, only because whatever we learned over the years, what we best practices, what we practiced in our Foundry, we wanted to share with the Foundry fraternity. As a Foundry fraternity, as a Foundry team, we get benefited together. So we wanted to support Indian Foundry industry to become world class. So by design to manufacture, by productivity improvement, quality improvement, cost competitiveness, use of technology for efficiency improvement, improved on-time deliveries, customer satisfaction, and enhanced collaboration with the customers, and product redesign for mutual benefits. So these are the objectives of my presentation today. So let us go to the main content, the product redesign. We have a couple of examples on how we redesign the product for the mutual benefit with the customers. So the hole, which is called grease hole, that is for the pumping grease into the gear assembly, which is inside. If you see the close-up, the hole look like this. The diameter of the hole is 6 millimeter, and about 10% of the times we used to have hole blackage. We know the hole is formed by the core because of there is only a 6 millimeter diameter, about 6 millimeter length. Always it is to fuse. 10% of the times either we had to reject or we had to spend a lot of manpower to remove the core blockages. So to overcome this, we have redesigned the hole without compromising fit, form and function to the size of 6 into 10 millimeter. After implementing this, the defect is 0. Not even a single instance after implementing this we had a core blockage in the casting. Interesting. So this technique used is called why analysis. Always we have to question ourselves. We should not question others. We have to question ourselves. Why blockage? Why? If you question ourselves for the 5 times, 6th time you will get answer. Let us go to the next example. Again, this is also on the product redesign. There is a small pocket in the Sasa body casting, which also we experienced about 5 to 6% of the cases the mold used to break in a slot. So that is hard to remove. Sometimes we should request to remove this by the machining. It was not that easy. Then again we applied YY analysis. Then we thought let us enhance the slot size so that mold never breaks. And why there is a reason for enhancing the slot size. Whatever we enhance, that get scooped off in the machining. So finally there is no impact on the machined casting. So whereby we are able to eliminate the mold breakage to 0. So after implementing this, there is no evidence of mold breakage in the Sasa body castings. So this is also again we applied the technique called YY analysis. Then third one is also on the product redesign. This is a ADB air disc brake housing. So we have a sensor pad lock which is about 6 millimeter in diameter and 6 millimeter length. It is a very small projection in a large body of 20 kilograms weight, and this is formed by the core. So when the core is painted, a small slot of the paint get filled up with the core paint. So one day suddenly about 200 bodies got rejected because the core paint got settled in this, and the people in the molding did not notice. So that triggered us to think again why. So we found a solution for this as well. Then we worked with the R&D, got the product redesigned to the size of 7 into 10 millimeter by keeping the height 6 millimeter, which led to 0 defect. After modifying the design, not even a single instance we had a mold breakage or a profile issue in the casting. So again we achieved 0 defect by applying YY analysis. Keep moving. So this is a 5th wheel mounting bracket on a large trucks in Europe, mainly on large trucks. So there are 6 holes. These are formed by the cores. I think you cannot see this. By the cores. So always there has been like the slot is formed, about 50% of the slot is formed by the core, another 50% is formed by the mold. Obviously there will be a gap between mold and the core. There will be a flash. While puncturing the flash, we encountered the slot oversize. The no-go is answering, whereby we had some rejections. We had a customer complaints as well. Then again, YY technique is applied. We redesigned the slot by shifting the parting line to one side without compromising the fillet on the top, as shown in the picture here. By doing this, so we achieved no flash, no-go answering. We fixed this problem by redesigning, just shifting the parting line. Again, the technique applied here is YY analysis. So hope you're all enjoying. So next one is on the quality improvement, is a shrinkage elimination. The part is called connection housing. It goes to the diamlo. So there is a M20 hole. Always about 25% of the parts were getting rejected because of a shrinkage in the threaded hole. Again, why? So because we are not designing the product, customer designed the product. They designed like a solid hole. So they do pilot drilling and they do the thread milling. So we had no choice to produce part like this. Then again, we worked with the customer saying that if it is M20 as a threaded hole, then pilot drill will be about 17.5, then main drill will be 18 mm. Why can't we introduce a core so that the modulus at the particular location can be brought down significantly? So customer agreed. We modified the core box, one cavity. We poured the castings with this, got it machined, no shrinkage, zero defect. Is gone from 25% to 0% rejection. Again, another example of shrinkage elimination quality improvement project. This is again a SASA body. So there is a tail. We drill in the tail. By design, it is a solid casting. We make a pilot drill and the main drill. One particular day we had a huge rejection because of shrinkage in the tail hole. Then again we applied YY analysis. We find that the stress concentration and the modulus at the particular location is very high. So we had no choice to reduce the modulus. We introduced a dimple, a profile on both sides of the castings so that the modulus at the particular location is brought down to the lowest levels. When you drill it, then zero defect. Not even a single casting got rejected after introduction of the dimple in the tail hole. So another quality improvement initiative by Madras Engineering. Next one is also on quality improvement. This part goes to MAN trucks in Europe, SASA body. Again, there is a blowhole and shrinkage in the pinion bore. So based on the analysis, we found the significant modulus is exactly at the location where the defect is found. Then again, we use tools and techniques to detect and prevent the defect. So we increased a core profile towards the pinion bore to reduce the modulus at a particular location so that the shrinkage gets pushed outside of the defect location. We got it simulated, found that the simulation results are effective. We have implemented on the part, and the core box is corrected to have the additional profile. We achieved zero defect on this product as well. Again, technique applied is YY analysis. Next one is on the quality improvement as well. It is a case through shaft. So about 10% of the parts used to get rejected because of the cold metal. At the top, we can probably see this, with the cold metal and the casting. 10% of the parts used to get rejected because of the cold metal. And careful examination, we found that there is a bottleneck. The wall thickness found to be within specification, but it is on the lower side of the specification. So we found that is a root cause, that is a bottleneck which is preventing the hot metal reaching the topmost point where there is a more wall thickness. Again, we corrected the tool to have wall thickness on the higher side of the tolerance. We did not change any specification. We exactly followed the customer specification. From the lower side of the specification, we moved this to the higher side of the specification. That's the only difference we made. So this is a change. Cold metal becomes 0. One more example on sand drop elimination. So deliberately we made it dull because there are a lot of getting intellectual properties involved in this. So the filter location normally in the DESA vertical molding system, the filter always on the top. Then that was leading to heavy sand inclusions, heavy inclusions. So this is mainly because based on, again, we applied why sand inclusion, where the inclusions are coming. It was not that easy, almost a week we spent along with the team. Why? Is it inclusion coming from the metal or inclusions generated within the mold? We made a diagrams on the board, we did simulation, and later we found that when you pour hot metal here, there is a filter. So the incoming variance is almost eliminated because we have the filter. There is no inclusions coming through the metal, because later we found that all the inclusions are generating within the mold. And also we identified that the gap from here to here is about 300 millimeters. When metal is poured, it is directly falling into the bottom, and then it is taking a turn and going, and there is a choke here. From the choke it is passing into the casting cavity. So the turbulence which is created within the mold is leading towards the sand drop. Then we have modified the filter location. We just moved filter location from top to bottom. Earlier, before doing this, we used to have about 12 plus 8, 20% of the parts used to get rejected. After introducing this, the foundry rejection is less than 0.5%. The machining rejection has come down to less than 2%, straight from 20% to 2.5%. This is interesting. This is a mismatch detection and prevention. This project got the Kaizen Award on 4th of this month. So this is a unique the technique which is used at MEI Foundry. We know these are the two halves of the patterns. This is a mismatch pattern, SP and PP halves. We just provided a small projections on the pattern that will create a pocket which is exposed outside. The projection in the pattern is creating a void or a pocket on the mold which can be seen from outside. So if any mismatch inside, that reflects the mismatch that can be seen with the naked eye from the outside. So the middle one is from the side, the last picture is from the top, center one is a down sprue, and these two are the mismatch detection pockets. So once the mold is made, we take a glue gun, fill the cavity with the glue. This is a filled mold. We take out a glue sample and check the mismatch. Even without checking the glue, we can, with the naked eye, we are able to detect the mismatch inside the mold versus what is seen outside. So otherwise, earlier practice was to pour molds, mismatch molds. It takes 2 hours to come out, then blast it, go to quality room, inspect. It takes about 3 to 4 hours. Within 3-4 hours, we would have poured tons of castings. We used to have heavy mismatch and lot of issues. Everything is prevented now, is almost come to zero today. Next one, hopefully is the last one, is productivity improvement. So there is a match plate. Again, it is hidden. There are 7 rings mounted on one match plate, because other match plate has to be blank, because we cannot produce on both match plates. So how do we improve the productivity to 2x? That was the thought process. Then again, we went through the brainstorming session. Then this is the ring produced out of this. We used to get 7 rings for every shot. We modified the pattern to make double, back to back. So productivity become double. Now only challenge is how do we slice it to become 2 parts. We are working and a slicing on a lathe, so 1 become 2. So the productivity is doubled. 7 cavities per match plate become 14 per match plate. Last one, shipment handling is very interesting. As I explained, like we produce 1 million products from 243 various line items, shipping about 25 to 30,000 pieces from the foundry within 6 hours of pouring is a big challenge. So this is how we used to ship earlier. Then we converted them into a dedicated designed bins. You can see there are 10 columns, each will have 80 parts. We are certain that exact quantity will go, exact product will go. About 100 parts look similar, 100 varieties of Sasa bodies look similar. So this is designed such a way that there is no wrong part goes into this, and there is no excess or less parts goes into this. And also we introduced a QR coding system. Once we scan it from the quality, it goes and sit in finished goods. If you scan again, it goes to the ERP, the invoice get automatically printed. Just go to the printer, take the invoice and then ship. You don't have to recount and pack. So to that extent, we made automation. So disclaimer, so we all know that every foundry is unique. The techniques or ideas shown here are implemented in MEI foundry. Doesn't mean that they work in other foundries, because of every foundry is unique. Because of material of construction, what we use here may be different from your foundry. The molding line may be different with your foundries. The sand system should be different. Gating design is unique to the foundries, and plant layout is different with respect to the cooling time, and support from customers. Because most of our products are our own products, so we have access to go to R&D, engineering, sit across the table, find fit, form and function. We can argue with them and get modification. Drawings modified very easily. It's not going to be that easy when you are talking to the external customers. That is one challenge you have. However, we got it done with Daimler in one of the case. So with this, I have a small video before I close. So let us be like Black Donkey.
Thank you, sir.
Any questions, I will be happy to answer.
Any questions to T.S. Rao, sir? Your dedication to improvement is evident and inspiring. Thanks for setting a great example to all of us here. Now we request Mr. P.V. Ramaya, Council Member Chennai Chapter, to felicitate Mr. T.S. Rao with a traditional Angavastram. We invite Mr. Shaktivel R. Tirunakavarasu, immediate past chairman, Chennai Chapter, to present a memento to our esteemed speaker. Thank you, sirs.